I'm going to do a video about the quadratic formula and how to derive it using an example that we used in a previous video, and also by completing the square and showing the algebra for it to derive the formula. So we used x squared plus 9x plus 20, and we factored it. So if I factor by grouping, for example, we can go x squared plus 5x plus 4x plus 20, because if I broke the 9 down into something that's multiplies up to 20, so 5 times 4 is 20, and 5 plus 4 is 9. So now we can group these, and we get x times x plus 5 plus 4 times x plus 5, because we divided each of these by 4 and took the 4 and put it outside. So 20 divided by 4 is 5. And now we conveniently have x plus 5 and x plus 5, and we have something multiplied times them in each case. So we can actually just factor out x plus 4 with this. We can go x plus 4 times that same x plus 5, but just put 1 time. Now, this is equal to this, and we can use, for example, just use like 5 as an example. 5 squared is 25 plus 9 times 5, which is itself is 45. So 45 and 25 is 70. 70 plus 20 is 90. So if this is 5, we have 5 plus 4, that's 9. If this is 5, then that's 5 plus 5, that's 10. So 9 times 10 is 90. We get the same amount. So this is correct. In fact, if we multiply this out, we have x times x, that's x squared. Then x times 5 is 5x. And then 4 times x is 4x. And 4 times 5 is 20. We add these together, we get x squared plus 9x plus 20, which is the same as what we started with. So this right here is kind of convenient because it's a product that equals that full amount. This is different than that. This is different expressions with x, or with the power of x to the 0, which is, so if you take x to the 0, it equals 1, right? So this is just x to the 1. This is x squared. These are descending powers of x. So we have 20. This is basically 20x0 here, right? Whereas this is just two different amounts multiplied together to equal the same amount as that. That's convenient here because if we have a rectangle, for example, and it's x plus 5 and x plus 4, these multiply together to equal whatever area this is, right? So the example we used, it was 90, right? And I showed you in my last video that you can make shapes out of these, put them together, and you can fit it into this larger rectangle and that they equal the same thing. And just I showed you how you could organize those shapes for it to kind of make sense to think about why it's factored that way. I'm not going to do that in this video, but when you want to find the value of 0 for like a function, so if we have a function of, like we have y equals x squared plus 9x plus 20, you could look at the xy axis. So this is the y-axis, this is the x-axis, and you have these different values for x, and then the amount that y equals at each of those x values. And you can plot a shape. So in this case, it's going to be something like, let's see, 3, 4, it's going to be something like this. the shape that represents this formula. What this is a plot at different values of x and showing what the value is. Like in this case, it was 90 for 5. But if you want to find where this intersects at the x-axis, this is a useful form to have this this in, because if this is also the same thing as x plus 5 times x plus 4, right? I just proved that to you, that these are the same thing. Now let's say we want to find 0 here. So at what value do you get 0 with this? Well, it's a lot easier to look at this and see it, because we know that if x is negative 5, for example, here, when you add it to that 5, it's going to be 0, right? And that's 0 times whatever amount this is. In this case, it would be negative 1. 0 times negative 1, which is 0 anyway, right? Or, so that's one thing. So x0 could equal negative 5. What else could it equal? Negative 4, right? So if this is negative 4 plus 4, that's 0. 0 times 1 is still going to be 0. So negative 4 is another value of this. So the quadratic formula, which I'm going to derive, makes this much easier for a lot of different examples where it's not as, it's not as convenient as, x plus 4 and x plus 5, or 4 and 5. And I'm going to show that, but first I'm going to show how to complete the square. Completing the square, though, allows us to actually derive the quadratic equation. First, I'm going to show you that if you go on Google, you can see that this is correct, that it's at negative 5 and negative 4. So I'm going to pause this real quick. So if you type this into Google, graph x squared plus 9x plus 20, it'll show you a graph, in fact, and you can zoom in. This here is the y-axis, and then the x-axis is this line here. And you can clearly see that that's a negative 5, and that's a negative 4. It still goes below, but if you want to find the exact values for that, they do work out to exactly what I showed you, negative 4 and negative 5, because of the x plus 5 and x plus 4 being multiplied times each other. All right, now I'm going to pause this. Okay, so I'm going to show you how to complete the square. And I'm doing this with this example that we've already just worked with, because we already know what it is and we know that it's correct. So x squared plus 9x plus 20 equals 0. So we're starting out in this form, and we're going to go through the various steps where we can basically have a procedure that we can use on any other one that's not easy like this. But because it works with this, even though we already know 20 works with 9, right? So first thing we're going to do is we're going to move that 20 over to the other side. We're going to have x squared plus 9x equals negative 20, because we subtracted 20 from both sides. The next thing we're going to do is we're going to come up with a different one instead of negative 20. And when we do, we're going to add it to both sides. We're also going to change the form of this to make it easy to factor, and also to come up with whatever we're going to use for the last one. So x squared plus 2 times 9 divided by 2 x. See how this is, we're just re-expressing it. We're showing it as 2 times 9 halves, even though this is 2 times 9 halves is going to be 9x, okay? And in doing so, we make it easy to find something over here that when 9 over 2x times 9 over 2, like the two 9 over 2's are multiplied times each other, we can get a value here. Because 2 times 9 over 2 is the same thing as 9 over 2 plus 9 over 2, right? And I showed you with grouping, with this example here, like when we have 5x and 4x, that worked for 20. But if we're basically taking 4.5x and we're saying we can add 4.5x and 4.5x, and then something, we can use something for this, right? So what we'll want to use is 9 divided by 2 squared, because that's this amount times itself. And this amount plus itself gives us 9x, which is 2 times 9 over 2. Now we're going to do the same thing to the other side. So we have 9 over 2 squared minus 20. Now I'm going to simplify this, basically simplify this side. We're going to go equals, I'm not going to completely simplify this actually, but I'm going to make it so that it works to derive the quadratic formula. So 9 over 2 squared is the same thing as 81 over 4, right? So we go 81 divided by 4 here. And we got to use something, in order if we're going to add these together, right? We have to make a denominator for 20. We have to have a common denominator. So to get the common denominator, what does negative 20 have to be? Well, we multiply negative 20 times 4. So we can go 81 minus 80 over 4, right? I mean, that's pretty easy to do the math on. That's going to be, right, 1/4, right? But I'm not going to simplify it. We're going to keep going. So, in fact, actually for this, we can simplify on this side. We're going to go, we're going to actually factor this out now. So we have x plus 9 over 2 squared. So it's the same thing as having x plus 9 over 2 times x plus 9 over 2. It'd just be the same amount. So just to show you again here, that's x plus 9 over 2 times x plus 9 over 2. So that's what this is right here, and that equals that. So now moving to the next line, now we're going to want to take the square root of both sides, right? So the square root of x plus 9 over 2 squared equals the square root of 81 minus 80 over 4. When we do this, we end up with x plus 9 over 2 equals, and because this is a square root, if we were to find the square root of this, it's either plus or minus, because the square root of the number could be a negative or a positive value. So because of that, we're going to go plus or minus the square root of 81 minus 80 over 2. So we simplified the 4 in the denominator, but the numerator, we're not simplifying that yet. So I can show you how to derive the quadratic formula. Now, we can move this to the other side. So we can have x equals negative 9 over 2 plus or minus 81 minus 80 over 2. These have the same denominator, right? So it's x equals negative 9 plus or minus the square root of 81 minus 80 over 2. Now, when we do this, we end up with, now I'm going to simplify it. So this equals -9 plus or minus the square root of 1, right? Which is just 1 over 2. So what that means, so if we're going to have to do two different calculations. We're going to have to do one where we have -9 plus 1, and we're going to do one where we have -9 minus 1. So we can have equals -8 divided by 2, or -9 minus 1 is -10 over 2, right? -10 over 2. This simplifies to what? -8 divided by 2 is the same thing as -4. -10 divided by 2 is the same thing as -5. So x could equal either of these values in order to get 0. So I've shown you that there's a convenient way that will work for any example, right? Because you can always just take half of whatever is here and then take it times 2, and then you can take whatever that half is and you can always square it and have that equal to 0, or actually equal to whatever was here that you moved over to the other side. Usually this one doesn't work, and so you move it to the other side. So in doing this, I've shown you already, remember that -5 and -4 are the values that work for it to intersect at 0. And I just showed you graphically too on the computer. You can look it up on Google. So I've shown you that this method actually will work, right? Now the next step here is to actually use what I've done here to derive the quadratic formula, which is basically just taking what I did, but with algebra, to show you like using actual, like x, and having the coefficients represented by letters. So this form right here is ax squared. A is 1 here, and I used a convenient example here first. Ax squared plus bx, so b is 9, a is 1, plus c, which is 20, equals 0. I'm going to take this, I'm going to do the same steps that we did here, but show it like this, because I can derive the quadratic formula using that. So here we go. Ax squared plus bx plus c equals 0. So the next step, we're going to move the c over to where the 0 is. So we're going to subtract c from both sides. So ax squared plus bx equals -c. The step after that, we're going to divide a from everything. So we're going to have x squared, because we divided ax squared by a, so we have x squared here, plus b divided by a x equals -c divided by a. And I know I showed you that we just jumped right to this step here, where we took 2, we split this up into halves and squared this here. I'm going to do that next. I didn't need to show you that here because it's not applicable really here. It's implicit because 1 is a, so we don't really need to worry about it there. But in other examples, when this is like 3 or 4 or 5 or 10 or 11, whatever this is, then you have to do that. But we didn't do that in that example. I just showed you that this method in general works. Now, we're going to take and make this 2 times b over a divided by 2 right? So we're going to go x squared plus 2 times b over 2a x equals negative c over a. I'm going to write a little bit bigger in the subsequent steps. So now we're going to actually do the, remember we took 2 times 9 divided by 2x, and then we did 9 divided by 2 squared. So when we do this, we're going to add this to both sides. So this is x squared plus 2 times b over 2a x plus b over 2a squared equals negative c over a. I'm going to put this part in before this other part, so like I did before. So we're going to have b divided by 2a squared minus c divided by a. So we've just basically added this to both sides, and we just we express this differently here. Now, we already know that we can factor this, and then we want to take the square root of that, what we get, and then take the square root of that side as well, right? So before we do that, let's see. Actually, I don't want to rewrite this, so I'm going to do a couple of steps at once, but because we want to make these have a common denominator here, I'm going to do that part in the same step. So we have x plus b over 2a. We'll do this too, actually, for this line. X plus b over 2a. See how we again have this amount for each of these. They're multiplied together, they equal that, the squared. Okay, equals, and then we're going to simplify this side. So we have b squared over 2a squared, right? 2a squared is the same thing as, since we have 2 here, 2 squared is 4, right? A squared is just squared. So we can go 4a squared. That's what this amount squared, because we're squaring the numerator and then we're also squaring the denominator. Minus, we have c over a. So what can we do to get this to be in the same denominator with this, so we can conveniently do the subtraction? Well, since this is 4a times a, because 4a squared, right? So we can multiply c by 4a, and they can share the same denominator, right? So it would be minus 4a and then c, right? So now in the next line, I'm going to express this as x plus b over 2a squared, because it's the same thing as squared, it's the same thing. And then in this step, we're just going to take the square root of both sides. But I'm just showing that this is the same thing as this. Two values multiplied times each other, right? To equal the same thing as this. Equals the square root of b squared minus 4ac divided by 4a squared. So it's the same as it was, just with the square root sign. It's going to be plus or minus though, because remember I told you it's plus or minus. So because we don't, let's see, where is it? Okay, because we don't know if this is going to be like the square root of 4 could be -2 times -2, or it could be 2 times 2, right? It can't be -2 times 2 because it wouldn't be the same number. But it's going to be plus or minus, and we don't know which one it is. And in this case, it matters because the square root could be either one, and we don't know which one it is on the number line. So that's why we do plus or minus, to emphasize that. Then we can simplify this. So now this becomes x plus b over 2a equals the square root of b squared minus 4ac. We can't do anything with this 4 because it's still there's still subtraction here. And we can't just take the square root of these because these are not squared here, like c isn't squared and a isn't squared. So we have to leave this as it is right now. But on the bottom, we have 4a squared. And if we're taking the square root of we can take the square root of the numerator and the denominator. And as I showed you, this is the square root right now. But for the bottom, we can simplify this down to 2a because the square root of 4 is 2 and the square root of a is a. So it's going to be over 2a. Now, we have this being added on this side. If we subtract this on this side, we can just have x. So x equals negative. And notice that they have the same denominator. We have 2a here, and we have 2a here now, which is really convenient, right? So now we have negative b. Actually, let's go plus or minus. And then we have negative b. I'm sorry, forget the plus or minus. It's the same thing to do it this way. So negative b plus or minus the square root of, I don't leave myself enough room here, but it's b squared minus 4ac. And then the denominator is still 2a because both of them were 2a, right? So when we use this, that's sad because the actual one, that's the quadratic formula, is the obvious one. So I'm going to rewrite it right here. So it's x equals negative b plus or minus the square root of b squared minus 4ac over 2a. That's the quadratic formula. So if you look at these steps and you compare them, I think I've pretty much shown you that it's the same, but just going back to the beginning again. We moved this to the other side, which we did here. So we have ax squared plus bx minus c. So we have minus 20 here. Then on the next line, we divided by a, which you can't really see here. We basically skipped that, but you had to divide by a on both sides because this isn't, in more complicated examples, this isn't necessarily just going to be x squared. It could be some coefficient in front of x, and you have to divide all of them. So that this becomes x squared by itself. Then the next step here, we broke this down, like we broke the 2 times 9 divided by 2. But we don't have to do that to the side because it's still equal to itself. It's just expressed differently. Then on the next line, though, to find the amount that would work with the coefficient for x, that's going to be the same thing as 1/2 times 1/2 of this. We had to add this to both sides. So just like we took 9 over 2 squared and we added to this side and added to this side, we did that here with this and this. Then moving to the next line, we express this as like x plus 9 over 2 times x plus 9 over 2. That's this right here. And we have that equal to 81 minus 80 over 4. So if you look at this, remember 81 is 9 squared, right? So that's, and remember this is b, so the term that's x is b. So I showed b is squared. When we got the common denominator here, b squared is the same thing as 9 squared, right? Which is 81 squared. And we're subtracting 4 times a times c. So let's look at 80 here. 80 is 4. So what's 1/4 of 80? That's 20, right? So 1/4 of 20. I'm sorry, 1/4 of 80, that's 20. And then c, c is already 20 right here. So this amount, and since a is 1, so remember it's 4ac, so the a is just 1. So if you just ignore the c for a little bit, I'm sorry, the a, it's just 4, -4 times c, right? So it would be -4 times 20 here, because this is already 1. And that's what we have. That's why I kept this like this, so we could go back and look at this. And then on the bottom it's on the bottom it's 4a squared. A is 1, because this is 1 right here. So 1 squared is just 1, right? So 4 times 1 is 4, and that's what we did here. We got the same thing. So I'm just showing you that even though a is 1 here, it's still the same. And I'm going to show you with another example that it works out as well. Okay, but moving down to the next line, we took the square root of both sides. That's what this is here. So we're taking the square root of this now, and we're doing plus or minus. So the square root of 81 minus 80 divided by 4. And then we simplified this. In the denominator, we were able to simplify it down to 2. And indeed, after we took the square to the side, 9 over 2, these have the same denominator, just like they have the same denominator here, 2a on both sides. And then we were able to simplify it down to, remember this negative 9 over 2, we can move it, 9 over 2 we moved over to the other side, and then we put it together because it's the same denominator here. And when we did that, notice that this -9, what's 9 on here? 9 is the same as the 9x, right? So 9 is b, and that's b. So if you look at this, it's x equals -b. So indeed, it's really the same thing. And the b squared is what? 9 squared, so that's 81, like I said. And then 80, the 4ac, over 2. And since 1 is a, these are the same thing. So indeed, I've shown you that we can derive a formula for what we did there. This formula at least works for this one, and I've already proven this with different methods, that you get -4 and -5. So now when we find these values using the completing the square method, we want to take the opposite value. So now instead of -4, it's going to be +4. Instead of -5, it's going to be +5. X plus 5. And when a here is equal to 1, that's all you got to do to know what this is. So this is this factored right here. It's not quite as simple when you use the quadratic formula and there's a number here. You actually have to take that number and you have to multiply it. So actually it becomes, it's got to be a, whatever a is, times these in the parentheses when you want to factor it down to like equals 0. Or even if it doesn't equal 0, this still works because it's the same quantity anyway. but you're using a formula to do it. So now I'm going to show with a different example using this methodology here, actually just even using this right here, that is correct without even going through the same completing the square steps with a different one. I'm going to show that this formula still works anyway. So I'm going to pause this. Okay, I changed my mind. Actually, so what I'm going to do is use the quadratic equation, but without all the clutter. So I'm going to use this equation, and I'm going to show you that it works with the last one, just using that equation. And then I'm going to take another example and show you that it works also with that one. And then I'm just going to probably complete the square to go through and show you that it still works with completing the square. So if we have x squared plus 9x plus 20 equals 0. To use the quadratic equation, it's x 0 equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So now we're going to evaluate this with these different coefficients. So like I said, a is 1 for this. So if we just go down to the next line, it's going to be negative 9 plus or minus the square root of 9 squared minus 4 times 1, because a is 1, times whatever c is, and c is 20. We can also use 20. So even though I went through the procedure before to come up with another one, we're just going to use the original values. So using 20 here. I've implicitly already done this by going back and forth, but if it was hard for you to focus on like all the characters and stuff that I wrote down, we're doing this just with the formula itself. So 2 times 1. So the negative b is 9. B squared is 9 squared minus 4 times, then a is 1. C is 20, then divided by 2 times a, which is 1. Okay, and just to show you again that that quadratic formula is there. Actually, let's look at a neater example. It's the same thing as this one. Okay, now we're going to use an example like three. So this is actually just take this away, I guess. Let's turn it over. We're going to use 3x squared plus 7x minus 12 equals 0. So notice this isn't quite as simple because they have to add up to this, they have to equal negative 12. And what would you use? Like there's 2 and 6, that would add up to 8, right? Or they still have to be positive, right? And the 2, you can't just subtract 2. If you subtract 2 from 6, that's going to be 4. So this doesn't, and then also you have to worry about this. So like if we took this times this, so that would be negative 36, right? There's like 6 and 6, like 6 and negative 6, that's going to even equal 0. 9 and 4, 9 minus 4 is still going to be 5. It's not going to work, right? So instead of doing it that way, we could complete the square like I already did and go through all those steps, or we could just use the formula that I derived, right? Which is the quadratic formula. So we can use, if we want to find what the x0 values are, we can go x0 equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And when we do this, this would be negative 7 plus or minus the square root of 7 squared minus 4 times 3 is a, in this case it's not 1, right? So times 3, that's a. Then c is going to be this last one right here, which is negative 12. So times negative 12. And then we're going to divide by 2 times a. So 2 times, and then a was 3 up here. So 3. Now we have two different answers because we're adding to negative 7 and we're also going to subtract from negative 7, whatever this value is. So we're going to have, if we simplify it a little bit further, it's x0 is going to be negative 7 plus or minus, actually I'm going to get rid of this here. I want to make it bigger for you guys. So negative 7 plus or minus so this is 49, right? 49 minus, and then this is going to be 12 times negative 12 is 144. It's going to be adding it though, because it minus a negative. So 49 plus 144 is going to be 100 and I think it's 193. Let's see, 49 is like 50, right? 50 minus 100. 50 plus 144 is going to be 194. And then minus the 1, because it's 49, not 50, is 193. So this is the square root of 193 in here, divided by 6. Because 2 times 3 is 6. Now, we can do, so if we do that, you can use a calculator for this, but actually really this is what it would look like. So now basically it would be, it's going to be negative 7 plus the square root of 193 over 6, or negative 7 minus the square root of 193 divided by 6. So the difference between it is plus or minus. So when we do this, like on a calculator here, we do negative 7 plus 193 raised to the 0.5, which is the same thing as the square root because it's 1/2 of a full power. When we do this, we get that, and then we divide that by 6, and we get this. So for addition, we got 1.14874 basically. And then for this side, we're going to do the subtraction. So we would have negative 7 minus 193 raised to the 0.5 and then divided by 6 is this, negative 3.4820, okay? So those are the two values we get. That's not very pretty. It's just as pretty to have it like this, right? But let's check and let's see if that's correct. So I'm going to pause this real quick. Okay, so this is graph 3x squared plus 7x minus 12. And if you look at where this is pretty close to 3.5, but just less than 3.5. Remember, it was negative 3.482, I think. Yep, and it's exactly on that right there. And then for the other one, it was like 1.149 or something. Let's see. 1. See exactly. So that is how you calculate it, and it shows it. And if we just zoom out, you can see what this plot looks like. So again, since it's the highest one is x squared, this is like an example of an even, what it's called, I think an even function or something. The odd function is when it's cubed. So for an even function, since you could have, if you have a negative value squared, it's going to still be a positive. If you have a positive value squared, it's still going to be a positive. It ends up having this general shape where it points down. If this is negative, or where it's symmetrical on both sides, on the left and right side, so on both sides of the y-axis, like it's symmetrical about the y-axis. But if it was cubed, it would look different. It would look like maybe something like this. But it depends upon whether this is negative or positive at the beginning. If this is negative, then it's going to be pointed the opposite direction. It's going to be like this. Anyway, that was extra information. But so we see that that's correct. So I'm going to pause this real quick. Okay, so again, these are the values that we saw. If we're going to put this into like a, if we're going to like put it like factoring, like in something like this, actually, we would go like this. So x, we have to take x and we have to subtract. So it has to subtract because this is positive. It's got to be the opposite because these were the values for 0. Because remember, x, whatever we have here, has to undo whatever this is to make it exactly 0, has to subtract. So minus 1.1, no, 14874, whatever. So we have to subtract that and then times x plus, because this is the value x has to be, the value we have to do with this, that we have to add or subtract to it, is going to be positive, right? So we're going to go x plus 3.4820. So this is what we would see, but also, if you look at this though, and you actually do the math on this, it doesn't come out to be the same as this, you know, possibly leaving you puzzled, which initially it did for me, and then I thought more about it, and you have to actually multiply by 3. So, and I looked it up, and that's what we're supposed to do to make it like an expression of a sum. It's because basically when we did what we did, for example, when we divided both sides by a, this was 0, right? So we have to basically multiply it by 3 again. But we still have the right values here for the actual 0 values on the x-axis. So every time that there's an actual value for a, we have to multiply it times this if we want to express it as the same value as this here. And it does work out mathematically too. If you go like, if you do use FOIL and you go through these, which I did, you'll see that they're like really, really close to the actual numbers after you multiply by 3. Like you get 2.33, 33333. If you multiply that times 3, you get, that gives you 7, because 6, and then that extra 3 times 3 is going to be an extra 1, which gives you 7. And then you also, it adds up to 12, negative 12. So this does work out. If you want to make it in this, if you want to show it in this form, though, you have to multiply times 8. And you have to use the negative of whatever these are for the values of x being 0. Now I'm going to show you, using that same one, that you can complete the square, and it does look like the quadratic formula. So 3x squared plus 7x minus 12 equals 0. A quick note, by the way, if there's no x squared here, do you think that you can use the quadratic formula? So if a equals 0 here, can you use this formula? And the answer is no, because you would be dividing by 0. But you can use it if you have no x, for example. You can use that. You may not need to, but that's just a point with this. But just because it would divide by 0 doesn't mean that there's no way to factor it either. But for basically kind of the definition of a trinomial, we're always going to have something here, like at least 1 or something. But that's just extra information. So now completing the square for this, the first step we want to take is to move that negative 12. I just want to make sure that you can see, look at the paper, okay, good. All right, so we're going to move that negative 12 over. It's going to be 3x squared plus 7x equals 12, because we subtracted negative 12 from both sides, so now this is 12. Then for the next step, we're going to divide by a, which is 3, so we'll have x squared. Actually, I'm doing I can do 2 steps at once, I guess, but we won't. We'll go plus 2 times 7 divided by 2 plus 7 divided by 2 squared equals 7 divided by 2 squared minus or plus 12. So now, again, we broke this down into halves and multiplied times 2. Oops, I forgot the x. So just like we did before. And then we had to find something where if we take this value times itself, what is that? Well, it's 7 divided by 2 squared. So now we basically have 2 times this is having 2 different ones that add together to equal what this is, and also multiply to equal this. This is what we'd want to use right here for our kind of like our makeshift C, if you want to put it that way. But C is still this, but using the same kind of factoring strategy, we want to come up with one that works. So now moving to the next line, we have to divide out 3. So we're dividing a out. So now it's x squared plus 2. Actually, I could have done it a step before. I think I might have done this out of order, but it's still fine. It's going to be 7 divided by 2 times 3 here squared, and then also I did it out of order, I guess, but it still works. 2 times 3 squared equals 7 divided by 2 times 3 squared. And we also have to divide by, yeah, so I did it on that step before last time, but it still works. So we can go plus 12 divided by 3. So just to show you what I mean, if you're not sure what I mean. In the first step, before we even, actually, no, I did do that. No, before we did this here, I already divided by a, and I should have done the last step, but it still is going to work out because it did it to all of them. And that's a lot less work, right? So if we did it the other way. So now I'm just going to simplify this actually. So x squared. I'm trying to decide, do I want to do that? No, I don't want to do that because I want to show you that it does work for the quadratic formula. So in this line here now, we're going to have x squared plus 7 divided by 2 times 3 times x squared plus 7 divided by 2 times 3 equals, and we can simplify, we can just, I'm going to put these under the same denominator over here and also do the squaring on this one. So 7 squared is 49, right? And 2 times 3 is 6, right? So 6 squared is going to be 36, right? Actually, instead of doing it that way, we're going to do it a little bit differently, I think. I'm going to pause this real quick. I don't want to confuse you guys necessarily right now, or maybe you're not confused, but it's a lot of extra writing. But what we did before was we took and we squared the 2, so it would be 4 down here, but we just went a squared, which is going to be 9, but or 3 squared if we want, but I don't want to do it like that because it's really confusing. So we're just going to go, we'll go 7 squared divided by, heck, let's just do it. So 2 squared is 4, and then times 3 squared, because we haven't squared the 3 yet, but 2 times 3 squared is 6 squared, right? And then that would be 36. 4 times 3 squared is 9. So 4 times 9 is 36. It's still the same amount, but I'm leaving it this way just so you can look at we can compare to the quadratic equation too. So now if we're going to add this though to this, what do we have to do with this one? So we already have 3 here, but we still got to multiply times the 3 and times the 4 for this one, right? So we end up with plus 12 times 4, right, times 3. Because this is 3 squared, but we already had 3, so we can just multiply times 3 here. All right, so the next step is, this is the same thing as x squared, or I'm sorry, as x, I did this wrong, I'm sorry guys, this is x, this is actually the 1 here on both sides. So x plus 7 divided by 2 times 3 squared, and then we want to take the square root of both sides. So equals the square root of this whole thing, 7 squared plus 12 times 4 times 3 divided by 4 times 3 squared. And it's going to be plus or minus that amount. You would be dumb by now because you do all the multiplication, so this doesn't even take this long. I'm taking a lot of time though to show you that it still is the same as the quadratic formula. So now we'd have x plus 7 over 2 times 3 equals, and we can simplify and rearrange this to make it more like the quadratic formula. We have b squared minus 4ac. So here, the 4 is right here, right? We can put 4 at the beginning. All right, let's see, 4, and then A is 3, and C is 12. But remember, 12, it's negative 12. So C is actually negative 12, and you notice that it's a plus here, but actually a plus is really minusing the C, okay? And that 7 squared is the B squared. So now equals plus or minus the square root of 7 squared plus 4 times, which is the same thing as minus. We're going to do minus, and I'm going to do negative. See, A is 3, so 3 here, times negative 12. And then that's over. We can take the square root of this pretty easily here. So we can have 2 times just 3, because this was 3 squared, but now it's squared, a square root. We took the square root of 4, and we're going to take the square root of 3 squared, which is 3. So times 3. 3 is A up here. And remember that in the quadratic formula, it's 2 times A. That's 2 times 3. The negative B is going to be negative whatever this is. So we're going to have, well, we're not there yet. Sorry. We're just looking at this part right now, though. So B squared, 7. That's 7 squared minus 4 times A, which is this, times C, which is negative 12. So now in the next line, we have x equals negative 7. And since these have the same denominator, so this is added, now we're going to subtract it. But since there's the same denominator, I'm just going to express them on the same line. So we have plus or minus the square root of 7 squared minus 4 times 3 times negative 12 over 2 times 3. So now this is the quadratic equation. So if we cover this up to make this a little less confusing right here, we have, you see this? Okay, good. Hopefully you can see this. Okay, negative B is negative 7 because it was 7. And then B squared is going to be 7 squared minus 4AC, like I showed you before. So now we can do the math on this, and so it's going to be 2 different answers, right? So we're going to have negative 7 plus or minus the square root of, this is 49 minus 144, because 4 times 3 is 12, times negative 12. 12 times 12 is 144. Since we have a negative here and a negative there, before it actually even was a positive, but we just broke it up so that you can look at the quadratic equation. So it's going to be 49 plus 144, and last time we established, actually never proved it to you, but I basically did, I guess, kind of, by showing you the whole thing worked, but 49, here, let's just do the whole thing actually, 7 squared minus 4 times 3 times negative 12. Ooh, I messed up on that. Let's just go 49 plus 144 is 193, right? So it's the square root of 193. And then divided by 6. So I'm going to do this for each one. We're going to start out with negative 7 plus the square root of, oops, 193 raised to the 0.5 is that, then divided by 6 here. We end up with the same number again. So 1.1487, it just keeps going. It's actually the same as this. This right here, same number. And then if we do the other one, you can already actually see that they're going to be the same, because so this is -7 plus, and we got that one. -7 minus, it's the same thing as plus or minus. These are the same thing. So I've just proven to you that it works either way. And the reason for doing it this way was to show you that those letters match up with the numbers, and that's why I left them unsimplified like that. Then for this case, like I said, we have to take 3 times in parentheses each of these ones, and we could get the actual factor. Like it would just be the same thing as factoring. So that's all I'm going to do in this video.